Hello, in this lecture, we will learn important statistic terminology. This is crucial because without understanding basic statistic terms, it is hard for you to go further. This lecture will clearly explain to you important statistic terms in a simple way. The lecture will cover six main points. First of all, we are going to learn what descriptive statistics and inferential statistics are. Then we will look into the meaning of population and sample. In the third point, we will learn what parameters and statistics are. We then delve into the measure of central tendency and the measure of variability in the next 2 points. Finally, we will calculate statistics using R. Before we start, I would like to introduce to you two good reference books. The first book is Statistic, written by Robert Witt and John Witt. This book is a great book for beginners. It will provide you a strong statistic foundation. The book is easy to read because the terminology was explained in a simple way through a real-life examples. It also has a great visual aid. You will learn basic statistical terms with a minimum effort from this book. The book is applicable since it uses many real-life examples. The second book is Statistic in Plain English, written by Timothy Orden. This book is good for both beginners and intermediate levels. Particularly, the book is useful for readers who may not have a strong background in mathematics. The books use everyday language to explain statistical concepts in clear, so it is easy to read. It is also applicable since it's based on real-life examples, particularly in social science. Now let's get started. We begin with descriptive and inferential statistics. So, what is descriptive statistics? Descriptive statistics refer to a branch of statistics that involves in summarizing and organizing data to make it easy to understand and interpret. Our figures and tables are often used to present descriptive statistics. There are two main measures in descriptive statistics: the measure of central tendency and the measure of variability. Measure of central tendency attempt to approximate the center of a distribution including mean, median, and mode. In contrast to the measure of central tendency, the measure of variability or dispersion attempt to quantify the spread of a data, and these include variance, standard deviation, mean, max, range, and interquartile range. Mean and standard deviation are the most common measure for descriptive statistics. We will delve more detail into the measure of central tendency and the measure of variability later in this lecture. Descriptive statistics is used to describe the result of the dataset without making any conclusions. To make conclusions for a larger population from a dataset, we use inferential statistics. So, what is inferential statistics? Inferential statistics is a branch of statistics that allow researchers to make predictions or inferences about a larger population based on a sample. It involves in estimating, testing hypotheses, and determining relationships between variables. Common methods in inferential statistics are ANOVAs, correlation analysis, and regression analysis. In the second part, we will learn what populations and samples are. A population represents all observations or individuals of studies interest, while a sample is a subset of individuals or observations taken from a population. For example, when you want to investigate the suicide of Vietnamese men, the population for this study includes the suicides of all men in the whole country. But if you're interested in investigating the suicide of only one province, the population of study is the suicide of all men in that province. So the population of a study depends on the scope of the study. To investigate the suicide of Vietnamese men, it is very hard to get the data of the whole country. So a survey was conducted on 1,000 men to estimate the suicide features of the country. The suicide of 1,000 men from this survey are called a sample, and the sample size is 1,000. In life science, for example, agriculture or biological sciences, experimental designs are often have groups or treatment. In this case, each group is considered a sample. In this type of study, the population are not defined, and we often estimate the population parameters based on the collected sample. Another pair of terminology you should know are statistic and parameters. Statistics are the measure of sample features such as mean, standard deviation, and sample size. Parameters are the measure to describe a population. Parameters of a population are also similar to the measure of statistics such as mean, standard deviation, and population size. However, the symbols for parameter are different from statistics. Mu is a symbol for the mean of a population, while x bar is a symbol for the mean of a sample. Sigma is a symbol for standard deviation of a population, while S is a symbol for standard deviation of a sample. Capital N is a symbol for sample size of a population, while small n is a symbol of a sample size. Parameters of a population are often not known, but it can be estimated from a sample. That is the reason why there is inferential statistic. Up to now, you know overall statistic terms including descriptive and inferential statistics, population and sample, and statistic and parameters. Now we will look more detail about descriptive statistics. In this section, we will learn the measure of central tendency. What are the measures of central tendency? The measure of central tendency attempts to approximate the center of a distribution and therefore determine the representative value of a dataset. Mean, median, and mode are three measures of central tendency. First, we will look into the mean. The mean is calculated by the sum of all individual values in a population or a sample divided by the population size or sample size respectively. These are the equations to calculate the means for a population and sample. Mu is the population mean and x bar is the sample mean. Sigma means sum of, and x is an observation value. Capital N is the population size and small n is the sample size. For example, this is a sample of 7 suicides. We calculate the mean of this sample by sum up all the suicides then divided by 7. The second measure of central tendency is median. The median is the 50 percentile. This value divides the observation of a sample into two equal halves, a lower half and a higher half. To calculate median, first we need to sort the data from the lowest to the highest. Then we identify the value that separates the data into two equal halves. The first step of sorting data is similar between the samples with odd and even sample size, but the way of identifying the median is different between the odd sample size and even sample size. For example, this is an example with the sample size of 7, an odd number. To calculate median, first we need to sort the data from the lowest to the largest. Then we identify observation that divides the data into two equal halves, and it is 39. When the sample size of a sample is an even number, such as 6 in this example, first we also sort the data from the lowest to the largest. Then we identify two observations that are at the middle of the data. The median is the mean of these two observations. Mode is the last measure of central tendency we will look at. Mode is an observation or some observation that appear most frequently in a dataset. For example, this data have two observations, 38 occurring two times, while all other values occur only one time. So the mode of this data is 38. With this data, there are two values, 38 and 40 appear two times. The rest value occur only one time each, so the mode of this data are 38 and 40. In contrast to the measure of central tendency, which attempt to estimate the center of a distribution of a dataset, the measure of variability or dispersion attempt to quantify the spread of a dataset. In this part, we are going to learn how to calculate the measure of variability, including variance, standard deviation, mean, max, range, and interquartile range. We start with the mean and max first. Mean is the smallest value, while max is the largest value in a dataset. We will calculate the mean and the max of this dataset with 7 observations we have already known from previous slides. To calculate mean and max, first we sort the data from the lowest to the largest. Then we can easily find the mean is 37 and the max is 43. After we identify max and mean, we can calculate the range of the dataset. The range is the difference between max and mean of the dataset, or it is equal to max minus mean. For example, the range of this data is equal to 45 minus 37, and it equals 6. Range gives us information how data spread between mean and max. And the range gives us some idea of how dataset spreading, but it does not provide how much spread of observation inside the distribution of a dataset is. However, interquartile range will give us more insight about dispersion of the data. Interquartile range, or IQR, is a range between the first and the third quartile of the distribution of a dataset. The first quartile, or Q1, is the 25th percentile, where 25% data falls below this point, and the third quartile, or Q3, is 75 percentile, where 75% of data falls below this point. So interquartile range is equal to the third quartile minus the first quartile. Clearly, this gives us more insight about the dispersion of a dataset when compared with the range between mean and max. In this example, we will calculate the interquartile range of this sample of 7 shoe sizes. First, we need to sort the data from the lowest to the highest. Then we identify the second quartile or median. It is 39. Then we calculate Q1 and Q3. They are the medians of the lower and higher halves, respectively. We can easily identify they are 38 and 41, respectively. So the interquartile range is 41 minus 38, and it is equal to 3. Range and interquartile range describe some information about variability of the data. However, we still do not know how data deviate from the mean, an important measure of central tendency. What measure gives us that information? It is variance. What is variance? Variance is a measure that quantifies how observation of a dataset deviate from the mean. It is the average of square deviation from the mean. We use square deviations rather than the deviation because if we use deviation, the sum of deviation is 0, and this has no mathematical meaning. The variance of sample is calculated as the sum of square deviation from the mean divided by the sample size minus 1 rather than the sample size to have more accurate estimation for each population. We will calculate the variance of shoe size of the previous sample. The sample size is 7 and the data is vertically arranged. First of all, we calculate the mean of shoe size and it is 39.57. Then we calculate deviation between each shoe size and the mean. The next step, we calculate the square deviation and then we sum them up. We replace the sum of square deviation and sample size into the formula to calculate the variance, and it is 4.95. Variance is very important in inferential statistics. However, you can realize the unit of variance is square unit of observation values and the mean. Therefore, variance is not suitable to use along with the mean for a report. To eliminate this drawback, we can use the square root of variance. That value is standard deviation. So, what is standard deviation? Standard deviation, or ST in short, is the mean of deviation between the observation and the mean of the dataset. These are the equations to calculate standard deviation for a population and for a sample. For the suicide example, we can easily calculate the standard deviation using the equation or calculate the square root of the variance. So far, you know the basic but important statistic terminology. You also know the meaning and how to calculate the measure of central tendency and the measure of variability. This understanding is very important for you when you perform statistical analysis and interpret the result. The measure of statistic can be easily calculated by a statistical software such as R, Python, or SAS. In the last part, we will calculate the measure of central tendency and the measure of variability using R. This is the interface of RStudio. First of all, we need to create a data. We name it X, we run the code, and then we double check, and this is our data. After we have the data, we can start to calculate the measure of central tendency. The first value is mean. The function to calculate mean is mean. We run the code, when we get the result. And then we can calculate the median. The function of median is median. We run it, and this is the median. The median is 39. To calculate the mode, we need to create a function. In the first code of the function, we use the code unique. This code helps you to identify the unique value. For example, in this data, 38 occurs 2 times. So you identify the unique value only 38. And then this code helps you to identify the frequency of observations. In this example, 38 occurring 2 times, so the frequency is 2. All the other observations occurring only 1 time, so the frequency is 1. In the last code, it used to identify the observation have the highest frequency. So we run the code, and then we can identify the mode. And the mode is 38. If your data have 2 modes, for example, in this case, 38 occurring 2 times, and 40 also occurring 2 times, we also can identify 2 modes. You run the code to create the data, then we run this code, and you can see we identify 2 modes, 38 and 40. Now we can calculate the measure of variability. The first value mean, we can run the mean, we get it 37, and the max, we get it 43. We also can calculate the range. It is max minus to mean. We run the code, we double click there, and we run again, and we get a range of 6. The next measure of variability is IQR, or interquartile range. The code is IQR in capital. We run the code, and we get the value is 3. You also can identify Q1, Q2, and Q3 by using the code quanti, and then we need to use the probability at 25%, 50%, and 75%. We run the code, and we can get 38, 39, and 41. And 38 is Q1, 39 is Q2, and 41 is Q3. And this one we use to calculate variance. You run the code, you get the variance 4.95, and the last one is standard deviation, and the code is SD. We run the code, and we get 2.23. This is all for today. I hope the tutorial is useful for you. Thank you for the watching.